welcome to this Kappa Institute interview. We welcome Kenichi Saikawa. Thank you for being here in this interview and in the seminar you did yesterday in the university here in the University of Zaragoza in the Department of Theoretical Physics. Here we are three students. I'm David.
I'm Íñigo.
And I'm Jorge.
Just to begin, what can you tell us about you? Your motivation to study science or your background?
First of all, in my case, my motivation to study science or physics originate from my experience of my childhood. So when I was 12 years old, I had the opportunity to go to Indonesia, and there I saw some stars there, and I knew that the appearance of the star is different from what we saw in Japan, because Indonesia is located in the south part of the southern part of Earth. So then I'm very interested in the stars itself, and I'm interested in the question that how stars look so different from the place, and I read some books about the science or universe. Then I knew that the scale of our usual life is very small compared to the scale of the stars or universe. Then I am getting very interested in these underlying questions rather than the stars itself. Then when I entered high school, I decided to learn physics, study physics, to be able to answer these questions. And then I continued to study, and now I'm still on the way to investigate this structure of the universe.
Thank you.
And as students, we think it's a huge decision to leave our country and our culture. And so, was it hard for you?
Well, in my case, moving is of course hard, but I moved to the different. I'm now living in Germany, and I moved to Germany when I was doing first postdoc, and at that time I already knew that many people doing postdoc moved to the other countries and continue to research. So I have in this sense, I had no hurdle about this. So in order to do a good research, it is not good to stay in the same country. And if I can do better research in the different places, I'm happy to go there. So I accept this situation as a researcher. So I just moved to Germany to do a postdoc.
Okay. Why did you choose dark matter and not other things, other field in physics? Why dark matter and cosmology?
First of all, I'm interested in general cosmology, and why I'm doing dark matter is just I can do particular things for the dark matter, but I'm also researching different aspects of cosmology, for instance, inflation or gravitational waves. And although my main priority to work is dark matter for the moment, but I'd like to enlarge my research field, focus to various aspects in the early universe cosmology in the future.
I see. And an easy one. Which is your favorite candidate of dark matter?
So for me, it's an axion.
And yesterday in the talk you did, you have talked about axions and also like particles, and axion-like particles. Sorry. And what's the main difference between the QCD axion and the also like particles?
So the QCD axion is by definition the field are coupled to QCD, and the field that does not couple to QCD should be understood as axion-like particles. But as you saw in my previous talk, this is the matter of the basis you are considering. If there is a mass mixing and we focus on the mass eigenstates, both fields could couple to QCD. So in this sense, this distinguishment is not the right thing, but this is a matter of the basis.
Kenichi, you have researched on topological defects during the early universe. What can you tell us about that?
You mean the topological? So the topological defects is some object which is created in the early universe. When some symmetry is spontaneously broken, then the spontaneous breaking of symmetry implies that the universe takes one particular vacuum, but from the causality reason, the region taking one particular vacuum is limited by the size of the horizon. So there will be some different region in the universe where the universe taking a different vacuum, and there should be some non-trivial field configuration between these different vacuum regions. And sometimes it appears as the point-like or vortex-like or seat-like. Then this depends on the structure, vacuum structure of the theory. Then according to this structure, we call it as strings or domain walls or monopoles.
If such objects like cosmic strings were formed, they would not redshift as ordinary matter nor energy. Is that a problem?
Well, also it depends on the structure of the defects. It is known that for the cosmic strings, it might not be problematic, but for the domain wall, it might be a problem. This is because the dimension of these objects are different and they are scaled differently. And for cosmic strings, it redshifts like radiations. But for domain walls, the redshift is slower than matter and radiations. And at some point, it dominates the energy budget of the universe, which causes some problem. So, according to the structure, one has to avoid this situation.
Kenichi, in the near future, what do you think would be the most interesting part of astroparticles or cosmology? What would be the topic?
I think the axion is very interesting, and there is some interesting perspective for future in axion physics, because of course we want to know the origin of dark matter, and the most famous candidate is a weakly interacting massive particle called a WIMP. But for the moment, so far, people do not find any clear signature of the existence of WIMP, and people are starting to consider different alternative candidates. And axion is one of the theoretically well motivated candidates, and also the interesting thing is that one can search the axions in the low energy experiment, and this feature excited many experimentalists, and a lot of new experimental technologies are developed. So near future, a lot of aspects are known about the actions, and moreover, action physics is related to the early universe cosmology. So we can know not only the particle properties of actions, but also we can know something about the early universe, which is very exciting, I think.
What are the main differences in the research environment between Japan and Germany?
One particular difference I felt is that in Japanese university, the number of secretary is not enough. So, and the professor has to do something different from research, and it requires some more effort and time, and it decreases some research efficiency. This is partially because the Japanese government maybe do not invest enough money for individual universities, and they had to reduce the number of secretaries. But as far as I experienced, this is not the case in Germany, and every research institute, they have enough number of secretaries, and they are very helpful, so that researchers and students can concentrate on their own research. This is one difference I experienced.
And what advice would you bring to students like us who are thinking to study in the future and focus their research in particle physics and cosmology?
One thing is that to have a broad interest as much as you can, because research focus in this field changes time in time, and you are forced to do something particular according to the trend on the research field. But in the end, what is important is have more fundamental skills to able to any questions you are interested in. So for this, I think it is better to learn various things when you are student during the student life, such that you can tackle any problems, whatever you want in the future.
This might be a very personal question, but are you proud of your work?
Yes, I'm proud of my work, and the most thing I think I like in my research is that I can do something new, which people never done before. So the purpose of the research is to increase our fundamental knowledge about nature. So we have to create something new, and maybe what I'm doing is a very, very small thing, but even if this is this is for sure something new for the human being in general. So this creating feature is the most proud of things. I think it is the most proud.
Mm-hmm. So your current motivation may have changed since you were a child who were looking at the sky.
Not particularly, not changing. I'm still on the way to know about the structure of the universe, which I thought in my childhood.
So thank you very much, Kenichi Saikawa, for this interview and for visiting us in the Kappa Institute and University of Zaragoza. Thank you very much.
Thank you.